Wow, I don't know about you guys, but this feels very surreal to me. A year ago or so, when we really got started along the path, I would never thought I would see the day that a project that came from Google was equally applicable to Amazon, equally applicable to Microsoft, equally applicable to private cloud itself. And then, being up here on stage from an Intel perspective, talking about it, it seems like there's a lot of things that are happening in the industry that we just would not have thought of, even just a few years ago. So to kind of kickstart that, why is Intel here? That's kind of why I do these discussions when we have time at Tectonic Summit or other places. I see some friends in the crowd that I haven't seen for a long time. Why Intel? So let me just raise of hands here. Who here uses Intel processors? Don't lie. Come on now. Okay, yeah. Who uses Intel software? Yeah, exactly, right? Just a few hands here. Not many people realize that Intel does a tremendous amount of work in the software space too. Now, while we don't have our own distributions typically of software, we do a tremendous amount of work with our partners and also in the open source communities. And talk about a little bit about why that is as we move forward. The most interesting thing that I've seen, let's say, over the past 12 to 18 months is containers, right? You cannot turn around in our industry without bumping into the container terminology. And the portability that type of packaging for applications and that type of delivery style for applications gives you is driving a tremendous amount of cloud innovation and cloud growth. 451 has said that containers in production usage and adoption of those has more than doubled just in the last year. There probably hasn't been a technology since virtualization itself in the early 2000s or so that has really been so pervasive in changing how applications are delivered into the cloud and into the enterprise space. And so we think this trend is actually going to accelerate and continue. We've seen massive amounts of technology innovation just happening. It's the singularity type of comment, right? That things are actually getting faster and faster and faster, and so we all have to keep up with those as we move forward. Virtualization itself has existed for a long time, dozens of years, whereas containerization has only been around for just a few, at least out in the public. Obviously, Google and others have been doing some work with that for quite a while. But really, it is taking the enterprise space and the cloud space by storm. And so we want to help facilitate that because that's what our customers are asking us for. That type of innovation and driving that type of innovation and adoption is something that is very near and dear to Intel's heart. So it's not just containers, right? Containers themselves are just an interesting packaging methodology. It's really Kubernetes that has shown itself as being the premier scheduler and orchestrator of this new style of technology adoption, right? The new application delivery concepts. And we're seeing massive growth, right? So, I think the last time I checked is like 40,000 commits, right? More than 4 times the nearest technology. I don't want to poke holes at anybody, but 4 times the nearest one and over 10 times kind of the nearest, competitive technology to that, if you will. We're seeing, Kubernetes starting to be the underpinnings of a lot of different offerings. Obviously, CoreOS with their Tectonic, Red Hat has OpenShift, and on and on and on and on and on. And so even things like KubeCon as an example, right? KubeCon sold out this year with, I think, 1,500 people, whereas last year, I think it was less than half of that. And next year, they're planning on a doubling again in size, right? So this massive growth of not only the community, but the adoption and the usage is what is terribly interesting for all of us. And it's actually driving the right types of shifts in the ecosystem, right? We're seeing the adoption of cloud technologies grow incredibly rapidly, right? And it is a very, very balanced growth across all of the different industry segments. Public cloud, right? The Googles and the AWSs and the Facebooks and Tencent, Alibaba, Baidu, like all of the names, right? They're all growing at an amazing rate. But so are the tier 2 and what we call tier 2 and tier 3s, right? The Huawei's and the Dropbox and the Apples of the world, Tata Communications, right? Even communication vendors like Verizon and Tata, they're all growing their cloud offerings. And then if you think about the private cloud side, this is the enterprise space, it is also growing at an even greater pace. And it is these types of technology solutions that make this type of technology adoption cycle available to everyone that actually drives not only the innovation, but the usage, as well as these new delivery styles for applications, right? I mean, if you think about things on your phone, mobile applications, right? Even just a dozen years ago, 6 years ago, if you'd have looked at the number of applications that you were able to use versus what you have today, as well as the quality, it would be very, very different then versus now, and it is just going to accelerate. And so we would like to see that type of innovation continue. So why Kubernetes? The most interesting thing that I kind of alluded to earlier is that not since virtualization, right, have we seen technology that is so pervasive across so many people that you would think are normally competitive with each other. And so the interesting thing is we've seen announcements from Amazon, we've seen announcements from Microsoft, obviously Google with GKE has it. Not only that, but on the private cloud side, we have OpenStack, right? That is, you can layer Kubernetes and containers on top. Tectonic, obviously, from CoreOS, as well as Cloud Foundry is starting to, put feelers and APIs and connectors into Kubernetes. There hasn't been a technology that I remember for a long time that allows you the portability, right? The true promise of what we've been, hyping as the hybrid cloud for, again, a long time. And we do think that Kubernetes and containers are the things that actually get you there. As a customer, as a vendor, as an end user developer. So this is why we are so excited to be part of this ecosystem. And that's why you tend to see our name on a lot of things. But it's always valuable for me to make sure that people understand kind of why Intel is facilitating these types of things. So it's not just about, hey, this is a great ecosystem. There's a lot of work being done by a lot of different people, right? So, from an Intel perspective, I mentioned before, we're also a software house. We have just short of 6,000 developers as part of the company. We work in everything from, the normal vendors that you think about, optimizing those for use on our platforms. We do a tremendous amount of work. We're usually either number one or number two contributor to Linux. We contribute into Kubernetes itself. We contribute to projects that surround that. And we'll talk about that a little bit as we move forward. But it is really kind of the collaboration that we see in this space that is really, really valuable. And we talked about it this morning, right? We want to continue to see the Kubernetes community being driven by developers, by operators, and continue to see the innovation happening there. From a selfish standpoint, from an Intel perspective, we want to make sure that we bring the silicon, right? The CPUs, the memory, the SSDs, right? The network cards. We want to bring all of the features that our customers pay for directly to the developers themselves, whether they know it or not, right? So the idea that we've been working on in things like Kubernetes and others is making sure that all of those accelerators, right, all of the things that make your applications run more smoothly and more performant are fully exposed for the developers to be able to use, especially if we can do it in an automated fashion where they don't even have to worry about, what they need to go expose to do that. So, it's very, very, it's a win-win situation for us if we can go do that because that helps our customers that have paid for our platforms and it helps us expose those up to those customers. When, I saw this interesting quote that Google sends letters from the future or something along those lines out. And so we saw this with Hadoop, obviously, with MapReduce years and years ago. We've seen this now with Kubernetes, right? And so when somebody like Google says, hey, here's an interesting idea or an interesting concept, or in this case, a fully blown software project that can get you the types of efficiency that they can drive with their infrastructure, you listen. And so when we started to hear word of Kubernetes, we started to talk to Craig, we started to talk to our friends at Google, and said, okay, what can we go do to help you in this area, right? We started to listen. And so one of the interesting things about that is, Alex calls it Giphy, right? Google's infrastructure for everyone else. And when you look at the tremendous efficiency that companies like Google and the other large cloud providers, right? We just heard from AWS a few minutes ago. They all have their own in-house systems, right? That drive the scale and efficiency that is required to be successful in this space. And so when they start to open the kimono a little bit and they start to kind of get those technologies out there to everyone else, we'd better listen. Because we're using their engineering and their innovation in the outside world to get the same types of capabilities that they do. And so that's why one of the reasons why we're here today, because we think facilitating, democratizing those types of technologies out into the public space is the way that we can all succeed. So there's a couple different aspects from this from the Intel perspective, things that we do typically. Remember, other than the CPUs and the other infrastructure parts, right, the NICs and the SSDs, that sort of thing, that you purchase through the various vendors, Intel itself, right, we don't sell directly to anyone here. We don't sell software typically to anybody here. So there's a couple different ways that we can help facilitate these types of technology adoption cycles. One of them is kind of the public perception of things. And this is why a few of us, Craig, who's here somewhere around, and myself and a few others, Bob from Samsung, and really kind of kick-started what we call the Cloud Native Compute Foundation, which is now the home of Kubernetes itself. The reason for that is whenever these new technology adoption cycles start to happen, there's a lot of facilitation that needs to go on, especially to get the enterprise adoption of these technologies, right? Having been an enterprise IT person myself way back in the past, you know that you want the confidence that the technology that you're using, right, whether it be in the public or private side of IT, is going to be around at least long enough for you to be able to use it, to be able to leverage it, to be able to get the technology that you need out of it, to get the innovation, to drive the right types of behaviors, the right types of TCO type of calculations that your boss is looking for and your livelihood depends upon, right, until the next one comes out. And so one of the big things that we did, the reason we kind of launched the CNCF is to start to build that community and that facilitation of that enterprise awareness around that. It's the same reason that Intel is a large sponsor and a big part of the OpenStack community, right? And I talked about that this morning. This is not Kubernetes versus OpenStack. They each do different things very, very well. And they're each technology spaces that we want to see innovation in. In fact, we've even been pulling them together, and we'll talk about that here in a minute. But there's a couple different things, like I said, from the Intel perspective that we do, right? One of those is to facilitate the community. So I think 2 years ago now, we launched kind of what we call the Cloud for All initiative, which is essentially kind of the external face of the things that we do. How do we get various partners, various communities? How do we help fund those communities? How do we help do interesting things in those communities to facilitate the adoption, to facilitate the innovation? So here's just some of the announcements and some of the partners that we've had during that time. But we actually do quite a bit more actually in the engineering space also. So one of the things that Go is the core language of Kubernetes itself, and is obviously one of the emerging things in this space. And so one of the things that we decided to go do after talking to a lot of the developers that were creating Go was, could we help them facilitate Go to be much more performant than what it was before? Obviously, when you are designing the silicon itself, you have a lot of in-house knowledge about how you can, improve pipelines and, just words that I don't understand because that is not my world. But, we set a challenge internally last year, and we said, okay, hey, can you take Go, right, a relatively new emerging language, but is key and core to the infrastructure space? Can we set our developers in-house on optimizing that? And the first year, last year at CoreOS Summit, I announced that we did, I think, 200%. Yeah, I think it was 200% improvement in different things like memory copy functions, et cetera, et cetera. I said, hey, that's not quite good enough because you always have to give them a challenge. And so this year they came back with an 800% difference, right? So they're leveraging things like the crypto functions like AES and I, the AVX and AVX2 instruction sets. So all of this, again, is open source directly into the upstream itself, and so we are going to continue to do that work in Go because, again, since Kubernetes itself is based upon the Go language, anything that we do, that we facilitate a better performance in Go itself, facilitates better performance and better stability in Kubernetes. Cloud Native Compute Foundation, we talked about that a little bit. So, one of the things that when we first kickstarted that and we talked to Dan Cohns here, the ED for Cloud Native Foundation, is Craig, myself, and a few others said, okay, what is going to be really meaningful for the Cloud Native Compute Foundation, right? To really get people to understand the goal of that foundation is to drive adoption, to facilitate and accelerate the maturity of Kubernetes and containers itself. And so one of the things that we did is we put together about a $20 million investment in a data center along with Switch down in Las Vegas, where we launched the CNCF Community Cluster. It started out in 2016, late 2015, early 2016. As I think about 512 servers, I believe the additional, we were waiting for some new processor to come out, and so everybody knows that those are out now, and so the next 500, I think, are either online now or go online within the next few weeks. So we've had really good response from this, right? So anybody that's part of the CNCF Foundation or runs an open source project can essentially, throw a request on GitHub under CNCF and basically then go be able to test their application at scale. Originally, it was focused on infrastructure type of things, right? So we've had IBM come in, right? And this is part of pulling together some of the, the OpenStack community with some of the cloud native community. So they did, OpenStack container management at scale on top of OpenStack, right? And those results are going to be, were shared and published at the Barcelona Summit for OpenStack. Red Hat's OpenShift themselves, right, have done Kubernetes scalability testing on there. We did, along with something called Boink, we contributed a bunch of the capabilities there to, do, kind of the folding at home kind of thing for Zika virus, right? So using containers and Kubernetes and those resources on those servers to actually do, good for everyone, but also being able to test things at scale. So kind of, again, a nice win-win situation. And there's 11 new technologies and new customers, if you will, in the queue right now to be able to use that. And then Dan came to me, maybe, I don't know, 2-3 months ago, and he said, hey, one of the things that we really want to start thinking about is, can we open up the cluster itself to people that have applications, open source applications, right? The MySQLs of the world, the Postgres of the world, the Cassandras, et cetera, and see if they can use the cluster itself. And I started to think about that, and again, so for those of us that have been in the Linux space for a long time, especially in the early IT days, right? When you had to set up a DHCP server or a DNS server or do something goofy, right? Like set up replicated MySQL or whatever, you typically went off to one of the the blog sites where somebody has already done it and documented it, because you didn't want to be the hamster on the wheel trying to figure it out yourself, right? And so you went to one of the how-to forge type of deals and you said, okay, here's somebody who's done this, right? And they put step-by-step capability, step-by-step the process, right, in place on there for you to be able to follow, and the caveats and everything else, and what files you need to go look for, and what configuration settings you need to go do. And so that was really interesting to me, because I thought, along with the CNCF Foundation, that if we could get application vendors to containerize their applications that maybe they haven't been containerizing before, orchestrate those with Kubernetes, and then drop them onto the cluster to do scale testing, but more importantly, to then start writing those types of how-tos and publish those, that can also increase the adoption cycle of these types of technologies, right? Because nobody wants to be, right, the first person to put something into production without having somebody else having, hopefully done it first and done the canary testing and given you the right capabilities and caveats that you need to look for. So the Cloud Native Compute Foundation has the cluster under their governance. If you would like to leverage that for testing that goes into the upstream or documentation that goes into the public, please put a pull request in there, and we will get you into the queue. We've also done quite a bit of work with CoreOS directly on Tectonic itself, right? And so we started really, we've been friends of CoreOS for several years now, working with them in the community, working with Alex and Redbeard and the whole crew. We love those guys. We really, really like their philosophy on securing, the world, securing the internet. And they do it a different way than most people think about that, right? They do it through ease of use and ease of adoption, and I think that's key. And so one of the things we've been working with them on is how do we start to take, right? We've seen good adoption around things like OpenStack, and I see Jonathan over there in the crowd. So since that is an open source platform, right, that is kind of a natural fit to layer things like Kubernetes on top of, right? That's kind of where we all started our thought process. But then one of the challenges, the key challenges that my team had was how do we go facilitate the ease of use and the ease of installation and operation of OpenStack itself, right? Remember, they solve two different problems. But if you look at kind of what we saw as some of the initial challenges, again, this is from our perspective of OpenStack and the adoption of that, they were easily solved by Kubernetes. This is one of those inception type of things that you run through. And we said, okay, well, if you look at OpenStack itself as just a large, complex system of services. Does anybody in the crowd here know what is really good at automating and orchestrating a large, complex system of services? Kubernetes, right? And so we set the engineers a task to go look at that. And so along with CoreOS and Tectonic, we actually can, I'm not sure if Alex, I can't remember when you demoed it last time, but driving OpenStack installation and operations and upgrade using Kubernetes, it's the over-under approach, right? It can actually drive infrastructure as a service as well as sit on top of that for the actual applications themselves. And so it's very, very interesting when you start to think about how these things actually can work together instead of thinking about how they can compete, right? That the actual innovation starts to become visible. We also, like I said, we really do like the concepts of securing the internet. And obviously, there's instruction sets that reside within the Intel CPUs that we've been using in the virtualization space for years to give the isolation between those processes that people have come to expect from a security and a performance perspective. And so we've actually worked with the CoreOS team to do the same thing into Rocket, to expose the VT instruction sets into Rocket so that you get the same or better isolation from an east-west perspective in containers that you are used to in virtual machines today. And then finally, on the technology side, Snap. Right? So interesting name for an interesting bit of code. One of the things that we found when we first started working in the scheduler and orchestration space is that it was, your scheduling, much like air traffic control, right, is only as good at placing the workloads as the information it has to use to place them. And when you have a wealth of instructions that can facilitate the optimization of applications, even simple things like encryption, right? So if you are running, an SSL load balancer, right, or you are doing encryption for your data at rest into a database or some other file for, whether it be legislative or other security reasons, right, that encryption can come at a cost. But AES, which is one of the, the in-silicon instruction sets, accelerators that we have in the CPUs, can accelerate that by 400%, right? And while that that's interesting in and of itself, it actually gives you a much more scalable performance envelope for those types of workloads, which is more important, actually, than the performance itself. But if you can't find it, right, it's like an airport in the fog, right? If you can't see the runway, you can't land the applications there. That's my joke for getting here late last night. So what we said is, okay, what would it take for us to go start to expose some of those capabilities that are actually on the platform itself, not only for what accelerators are there, but what's actually happening on the CPU? How do I know when I can put more workloads on that platform? How do I know when I should be having less workloads there? And we found, even at Intel itself, right, we had, I think, 12 different telemetry tools, right, that all did a little bit and saw a little bit of what was happening on the processor, but nothing that really saw the full landscape. And we've sat down, we talked with a lot of operators, and the first thing they said is agents suck, right? I mean, agents are just horrible, right, from an operations perspective, because, you know, I've got a dozen of them, they're each doing slightly different things, or I've got 3 of them, and if I have to upgrade one, it's interacting with the other ones, and I'm polling these things, or they're sending data, and it's a mess. And so we really started to take it from an operator's perspective view, and so we launched Snap, which is an open source technology. It's on GitHub. It's written in Go. So a very interesting thing. And what it does is it actually serves as kind of a broker for all of the things that we can pull out of the silicon and can expose that up there. And so we have some integrations with Grafana right now for their monitoring tool. I think we're going to start looking at other things like Prometheus. But more importantly, we've started to do work around exposing these capabilities into Kubernetes itself. And we have something that is opaquely named, I think some opaque number, or opaque, I can't remember what it's called. Maybe, yeah, so the idea is that in Kubernetes itself, we've exposed the capability to do tagging against what is actually on the CPU itself. And so you can actually, during your deployments of applications, if you know that you're going to be using OpenSSL, or you know you're going to be using some sort of vector instruction sets, you can actually key off of those in your deployment so that those workloads actually get placed on the platform so that you know you're getting the best performance you possibly can for those applications. And so that is some of the work that we've just done. We're actually working, I think we have one of the incubator projects right now that actually allow us to start using some of the telemetry capabilities that we see on the platform itself so that you know when should your bin packing kind of stop, and how can you protect those resources that are on there, those high value workloads from being impacted by some of the other stuff, you know, kind of the crapplications that may surround it. And so we're doing a lot of work directly into Kubernetes. A lot of that is from our position of strength, which is the silicon itself. A lot of that is actually happening through Snap. How do we take that telemetry? How do we take that visibility of what's actually happening on the platform and expose that up into the upper layers so that they can be used for the benefit? And so that's really what Snap is. And so, you know, please take a look at that. It's also, like I said, from an operator perspective, Nick on my team has done a phenomenal job of really making this, you know, very, very easy to use from a large-scale operations perspective. Right? So Nick came from building large clouds, and he knows the pain of these types of things. And so he really looked at it from his perspective as, you know, what would I want to go build from scratch if I didn't want to have to maintain something that I've had to maintain before. And so it's very interesting from that perspective. So kind of in conclusion, I know we've kind of been a little bit all over the map, right? That's kind of the way that we are at Intel. We do a lot of different things. But really, what I want everybody to take away from this is, you know, thank you all for being here. Thank you for taking this journey with us, and thank you for innovating. And let's keep that going, right? Let's continue to push and develop and, you know, more and more applications and more solutions built around Kubernetes, because we do truly believe that that technology is one of the most significant ones for workload, you know, portability that we've seen in a long time. If you have applications or infrastructure that you need to test at scale, talk to Dan, put in a pull request, get time on our cluster, right? Anybody that does any testing on the cluster is really good for the whole community, because there are lots of things that we find, even if it's not something that you're testing for. The operations team that we have working on the cluster finds things, oh, wow, okay, yeah, we see a corner case here. Let's go ahead and address that, right, before it pops up in somebody else's data center. And let's really work together to accelerate, you know, this cloud-native concept into the mainstream, right? You know, we're working on this educational process to get more and more developers and more companies out there developing in this style, right? Because, you know, typically when you go 50 miles outside of a large metropolitan area and you ask somebody what a container is, they think about the things that are on the back of trucks or what their milk is in, right? They don't necessarily think of this type of technology. So it's up to us as a community of vendors, as a community of users, as a community of developers, to spread the word, to get people to understand these technologies and get that adoption happening. So again, thank you for your time, and thank you for the innovation.